Now, why definitions matter? So, dictionary definitions are descriptive. They tell us how people commonly use a term. Example, Oxford, it says that AI, artificial intelligence, are computer systems that are able to perform tasks that normally require human intelligence. For example, vision, speech, decision making, and translation tasks. Conceptual definitions are normative and analytical. They set boundaries, resolve ambiguities, guide theory and design, like drawing a boundary around a concept. Not just what exists, but also what should be built. A good definition should have four qualities mainly: similarity to the common usage, that is the dictionary meaning; the exactness of the definition, that is clear, necessary, and sufficient conditions should be mentioned clearly and concisely; fruitfulness, how helpful or useful it is, and guides whether it guides research and building; and simplicity, elegant, economical, simple to understand, not too overcomplicated, and beginner friendly, right? So all these would comprise the four major aspects for a good definition. Now, practices in defining AI, PIDAI is the short form for that. Historical development. So in 1940s, computers were invented and quickly conceptualized as the giant brains. Computers were seen as capable of intellectual tasks, not just number crunching. Emergence of expert systems didn't distinguish between numbers versus symbols. Landmark definition by Newell and Simon in 1976. General intelligent action is behavior appropriate to ends of the system, adaptive to environment within limits of speed and complexity. Common shorthand, intelligence is ability to solve hard problems. Now, different abstraction of human intelligence. So every definition of AI chooses a slice of the human mind to mimic. These abstractions shape the AI systems that are being built. So there are majorly four to five, abstractions of human intelligence, as mentioned. First, we have the structured AI. Structured AI is basically intelligence is the mental capability produced by human brain. The goal is to get a model that is similar to the human working brain. Brain modeling or emulation, neuroscience plus AI overlap, assumes mind reducible to brain structure, and critique, maybe too reductionist, might miss cultural, social, and non-biological aspects. Now, behavior AI focuses on external behavior. If an agent behaves like a human, it is intelligent. Turing test is the best example. Critique, anthropocentric, assumes human-like behavior. Uh, but humans act through culture, biology, so copying behavior is not equal to the full intelligence. Now, capability AI, intelligence judged by problem solving capability of that AI. Proposal, replace the Turing test with an employment test given by Nielsen. Pass, if the AI can pass it, it basically means that it can perform jobs that humans usually do. It emphasizes usefulness over imitation. Next up, the fourth one is function AI. So organize the AI by cognitive functions, that is searching, reasoning, learning, planning, execution, perception, action, and communication. This is less anthropocentric, that is less roaming around humans, right? And is practical, used in AI textbooks. So critique leads to fragmentation, no unified definition. And finally, we have principle AI, which seek fundamental principles of intelligence like physics laws. Rationality is making best possible decision given history or experience. Critique physics envy. Intelligence is too messy for the neat laws. Now, the ultimate aim of AI, early years 1950s to 1980s, the dream was thinking machine or general purpose intelligence. Projects, the general problem solver, fifth generation computer systems, strategic computing. Failure was the AI winters. So, shift to realism, focus on narrow cognitive tasks, practical functions, praised as AI becomes a science, rigorous methods, real world relevance, less hype. But ambition declined. The grand dream of building intelligent systems was abandoned. Critics said that AI has become brain dead. It only can perform calculations and repetitive tasks, but it cannot think on its own. It is not no more an autonomous system that we used to think it would have become, right? So recent revival, new terms, human level AI, artificial general intelligence, and strong AI hints that original dream is returning. That is due to all these new terms being delivered out into the market. Now, philosophical metaphors, all roads to Rome, different approaches, structure, behavior, capability, etc., are different paths to the same summit, right? Blind man and elephant, each approach sees only one piece of intelligence. Route to the summit. Niels Nielsen said we have different base camps. For example, neural nets, logic, common sense, fuzzy logic, knowledge engineering, heuristics, developed by different scientists or computer scientists, you can say, and they all lead to a pinnacle, or basically the same summit, right? Shared resources but different starting assumptions. Mount Lu poems given by Su Shi, not sushi, but Su Shi. True shape of intelligence is hard to see while inside. The Birth of a Sun poem given also by same author, Su Shi. Intelligence may not always equal happiness. Warns against the glorifying intelligence uncritically. Now, mind versus computer, key distinction. So, computer program designed to do things in a predetermined, correct way, that is algorithmic. The mind is adaptive, works with limited knowledge, finds good enough solutions. Thus, computation is not equal to intelligence. Intelligence is actually capacity of an information processing system to adapt to environment under conditions of insufficient knowledge or resources. This definition was given by Wong. Right now, beginner-friendly core synthesis. So, defining AI is not just about dictionary words; it's about choosing what to imitate about humans. Approaches. structure, that is brains, behavior, Turing test, capability given by jobs, function, cognitive tasks, principle, fundamental laws. Early AI aimed for general intelligence, it failed. So the narrative shifted to narrow, smart tools, and now ambition is reviving. Good definitions must be clear, useful, simple, and normatively fruitful. Intelligence may be less about perfect solutions and more about adaptability under limits. Now, some questions: which AI definition approaches least anthropocentric? So the answer is function AI. What was Nielsen's employment test? So it was a proposed alternative to the Turing test. If an AI passes if it can perform human jobs, emphasizing usefulness over imitation. Now compare the five abstractions of intelligence in AI, that is the structure, behavior, function, capability, and principle. So structure is brain-based neuroscience links. Behavior, human-like behavior, Turing test. Capability, problem solving. If basically uh, an AI can perform human jobs and give an employment test, it would be useful. So problem solving capabilities are checked for the AI function, then cognitive tasks, modular approach, then principle, fundamental rationality laws, and conclusion is that each captures a fragment. Together they form an atlas of intelligence. Now, a case-based question. Scenario is that a startup builds an AI that diagnoses patients better than doctors, but doesn't mimic human reasoning. Which abstraction best fits? So that is the capability AI. Intelligence